the chiller, you press here to turn it on, and press here on the same button to turn it off. If you're not going to use it the next day or something like that, switch it off. Otherwise, the filter is gonna get clogged, and then we have to keep replacing it. Once the chiller is on, you will see that these three lights switch on. If they are not on, the tool will not run, which is a problem. If they don't turn on when this turns on, you have to let me know, because I have to go inside the machine and have a look what's wrong. But these three lights should switch on. Okay. After that, you will open this, open the hinge, and then you have access to the chamber. You have to make sure that this viewport, you can see through it. If you cannot see through it, it's a problem, because you won't be able to see if the plasma is strobed. So, if you cannot see through it, you just remove it from here. It has a piece of metal that holds it. You remove it from here, remove the capton, and place new one. That's all you have to do. Then you just place it back in there, push it all the way to the back, and make sure that you can see through. Okay? Then you have access to the chamber. This is the main chamber. This is where the sample goes. Maybe I will shine a little bit of light. This is where the sample goes, and this is where the target goes. We have two different targets, two different sources as well. So, to remove the sample holder, all you do is pull this one to the front, push this one to the back, and pick it up. Push up, rotate, and it brings down. You can also see the pin. You can see the pin, right? Yeah. Okay. Now you place the sample here. This is where the sample goes. You have these holders. If they can help you, that's fine. If they cannot help you, you stick it with Kapton tape.
Okay.
Okay? Try to use as little Kapton tape as possible, because, as you know, you have to wait for vacuum. If you use a lot of Kapton tape, Kapton absorbs a lot of humidity. You have to wait a very long time until you reach vacuum. So, don't use much, but make sure that the sample is not gonna fall down. Okay? So, you place it back. Again, rotate to the other side, clockwise in this case, and leave it.
Yeah.
Close this one, and close this one. The sample should be loaded. Okay? Now we are going to make sure that you have the correct target inside. To change the target, you push this one to the back, and then here is where the target goes. Okay? This is very important to really have a look how it is installed right now. So please film that one. Go inside. As you can see, there is a gap in between the target and the shield. This gap has to be there all the time. So when you remove it, make sure that the gap is again there. So you unscrew this. This is the main shield. Unscrew it all the way, and this one comes off. Okay? Then unscrew the second shield, which is the anode, basically contact for the target. Unscrew it, and this one comes off. Remove this one. This is the target. Okay? Once you have the target, you also have this pad. This pad is very important.
Okay.
You cannot place the target without this pad.
Okay.
Please don't do it, because you will break the tool. This pad needs to be there. So leave the pad there, and here's the target. This is nickel, I think, because it wasn't installed before.
Okay.
And we have a new one that is aluminum. We're gonna use this one today.
Okay.
As you can see, there is a difference between the targets. This one doesn't have a backing plate. Normally targets have a copper backing plate for cooling. This one doesn't have, but it's fine because it's aluminum. So it should be okay. So place the target there. It should fit perfectly, right? it has the pad underneath. Then place the anode contact, and you screw it in. You screw it down all the way. This one doesn't have to have a gap. This one should be all the way down. Okay? So screw. The second, you will place it and then screw it until you see the gap that is around maybe 4 or 5 millimeters in between the target. A bit more. Maybe that should be okay. As you can see, there is a gap there.
Yeah.
Right? Don't screw it all the way down. If you do it, you may damage the tool.
So leave a gap here.
It's not about that. It's here. The gap here. You see?
Okay, it's here.
Yes, that gap.
Okay.
You cannot touch a target without gloves.
Okay.
As you can see, there is a gap, right?
Okay.
To make sure, always make sure by using a multimeter. So you take a multimeter, ohm mod, measuring ohms, make sure that it's working. Okay, and touch the target. If it's conductive, right now it's aluminum, it's conductive. If it's not conductive, touch the edge, the inner edge of this, the inner edge of the cathode. Don't touch this, right? As you can see. So right now I'm touching on the target, and I'm gonna touch here, and this is 8 mega ohms. It's okay. Okay. If you got something in kilo ohms, there is a short. Maybe increase the gap a little bit. Okay. Or clean. Maybe there is.
So every time
there.
we should have a test.
Yes, you should test. If there is kilo ohms, it's not okay. That's a short. Mega ohms, as you can see. If you can see, that's 20 mega ohms.
Okay.
That's okay. That's not even close to be shorted. Okay. Good. This is my multimeter, so if you use it,
Yes.
use it back. Okay.
We are doing it just to make sure that it's insulated.
Yes, because if it's touching, then you're creating a short between anode and cathode.
Okay.
Right? If you have a short, you will never get a plasma because all the RF will be shorted. Okay? So after it's loaded, right now we make sure there is no short or anything. Close this back.
Okay.
It has to be closed. And make sure that there is a gap also between this shutter and the shield.
Okay.
Otherwise it's gonna be touching and this is not gonna open, right? This opens by motor.
Okay.
If it's touching, it's not gonna open.
Difficult.
Right? So we have two sources, as you can see. So this is source 1, this is source 2.
Yeah.
You can use either of them. We have two generators, so it's the same process for both of them. This is source 1, this is source 2, and this is an evaporation source. We never use it, it's not working, so don't even try. This one stays there, but these two sources work. Okay? So now that everything is loaded, target is loaded, sample is loaded, we are gonna close the door.
And for the target, if we want to change target, we just change this one.
No. If you want to change targets, this is nickel.
Right,
We're
yes.
gonna keep it on a box. But if you want to change targets, we have different targets here. I don't know. It depends on the material that you want to use, right?
So there is a particular target for a particular material.
Of course. So right now I installed aluminum, but for example, this is silicon nitride.
Okay.
This is tungsten, right? We have several of them. Tungsten again as well.
So but
Diana
the way
has been buying a lot.
is the same. We just like change it as the aluminum. We just put in like this.
Yes.
Okay.
This is palladium, for example.
So are these targets consumable?
Yeah, they are consumables. Yes.
Okay.
We have many different materials, right, that we have been purchasing. Silicon boron doped.
So after our using, so we should remove the target, or we just leave it here.
I mean, if you plan to use it, you can keep it. If you don't plan to use it, it's always better to put it in a box like this,
Okay.
and place it back inside the desiccator.
Okay.
Otherwise, you're just damaging the targets exposed to air, right? So, for example, this is a very bad practice. I don't know who did this. Look at this.
Okay.
This is terrible, right? Look at this. Terrible. But what can we do? So, anyway, you close it. You use the hinges because you cannot really push this all the way back. It's quite heavy. So you use the hinges. Use the other hinge. And as you can see now, we have this one as well. Before, if you see, right now it's open, right?
Yes.
The sources also switch off by themselves
Okay.
because it's interlocked, so that you don't electrocute yourself.
Like when we off, it will turn on the light.
Sorry?
So the light will be on. When
Yes, the light has to be on.
Okay.
And as you can see, you will also see the sources. They have an interlock.
Okay.
That when it's open, they are off. Now that they're, you see?
Okay. Okay.
Okay. So the light went on and the sources went on. Okay? Now, after you close it, you need to use this. This is the controller for the pump. All you have to do is press start. Start. Okay, you wait until this light goes on. It says base pressure. So it normally takes 2-3 minutes, depending on what you have inside, depending on how long the tool has been open to the air, depending on how much humidity. Many factors influence vacuum, but it normally takes 2-3 minutes. After that's closed, you can remove the gloves. As long as you're not touching the inside, you can use your gloves. Okay.
This is high voltage. We are using.
Yeah, it is very high voltage. This has to be kilovolts, right? We have an RF, we need to strike plasma.
Yeah.
Okay, so this is the difficult part for the training because we don't have much space. So let's try to distribute. I need to go in the middle because I need to be working here. And then, since you are
Yeah.
not the main responsible, try to stand there, but you have to be seeing this, okay? And I think you need to film the screen as much as possible because otherwise
Okay.
this is the most annoying part, to be
Okay.
honest, because it's very manual. But okay, so sit down. We don't have much space, which is very annoying. But normally you will find it like this. Okay? The tool is like this. This means that nothing is running, everything is fine. And normally you will also see it in this screen. So we have different things: next menu, next graph, next display, sensor information, and next layer. Okay, so it's pretty much self-explanatory, right?
Yeah.
Next graph, rate versus time, rate deviation versus time, basically a digital one, and power versus time is the one that we normally keep. Next display, same thing. You just have these things changing, but no need to change that. Sensor information, basically all this live sensor is dead. There's only one sensor, so we are not going to use the sensor anymore because the sensors are dead anyway. Okay. Next layer, if you are doing the position of one material and then you need to stop and deposit the next material, basically that's what it does. Next layer.
Yeah.
Right now it won't do anything. So next menu, you enter process menu, film menu, and system menu. System menu, do not touch. Never touch.
Never touch.
That's for me.
Okay. Never.
Process menu. Okay? Okay, right now we can see that also. In the meantime, we already got base pressure.
Out of 5.
Yes. So that's okay. That's good. So, process menu and film menu. Okay. There are two different things about this. Film menu is where you basically set the recipe for the film itself. Okay? So, this is what it means. we are going to check a film that is, for example, aluminum. Okay, so this one says source 2 aluminum, but since we have it in source 1 aluminum,
So like every target we can find here.
no, not every target. We have only a few that we have done before.
Okay.
Okay, and we only have 50. So one thing, please never change 44 to 50. Never change. This stays the same.
Okay.
All the rest, you can do whatever you want. Let's see this one, for example. We're gonna edit,
The one and at the end you want to change.
because these are special recipe films that you will know why we need them, and they shouldn't be changed because we need them for the process. Okay, so don't change 44 to 50. Not change, but the rest we can change. So
Oh, we can add also.
you can know that we only have space for 50, and all the 50 are occupied. So basically, you will have
So
to,
the registry is only up to 50.
yes.
Okay.
So basically, you will have to modify it. Right now, we don't have anywhere we can use. But we are gonna edit, for example, the copper sigma. So you click edit, and you have this.
Okay.
This one is where you see what you have. The P term, because you have a PID controller inside. The I term, the D term, the film tooling. This one you don't change. But basically, what you change is here, right? The material. What material it is? If you click this, you can change to whatever you can find. So let's say we're gonna find aluminum. You already got the rate, and enter, and basically that's it. Sensors you don't need to change, nothing from here. So previous menu. Now we're gonna also rename this, and delete. We're gonna call it we're gonna call it aluminum. I don't know how to change this. Okay. Yes. As you can see, this tool is very manual, unfortunately, and there is nothing we can do. So we're gonna call it aluminum. Save. And number 1 is aluminum. Okay. So that's the one we're gonna use now. And what you do is basically main screen. Now we're gonna go to the process menu. Okay. Process menu. This one we have up to 100. I don't think it makes any difference if you modify or create a new one. Right now we're gonna create a new one for training purposes. If you wanna modify one of the other ones, you're welcome to do so, because these are very old recipes. I don't think anybody needs them anymore. But they are useful as a reference point if you have something to do. Okay. So you first, since this one says empty, you have the option to create. This one, for example, has a name, so you can edit. Okay? But this one, we're gonna do 55, and we're gonna create. So when you come create, edit name first, obviously. So we're gonna call it training. Delete, and we're gonna call it training. It's very annoying to do, but what can we do? Okay. Great. We'll delete it at the end, but let's save. You see, training. And now we can edit. So select, edit, right? It's empty, so what you have to do is insert new. What you are gonna do is basically the one that you previously created, or the ones that you have here. Anything, you just insert normal. Okay. So now this is very important. Please remember, if you go here and insert new, you're gonna find two different things: insert normal and insert all the position. this is where we are going to use this. Okay, we are in source 1, so you are going to do G1. If you're in source 2, you do G2. Okay, so here, insert go down. Okay, we have G1. Now modify the code position first. So we're gonna edit, and this is very important. You are gonna switch on this one and change this one to source 4. Okay, this is what's gonna help you completely on terms of how long or this basically this is what measures how much the position has been there. We don't have 4 sources, that's why we chose source 4, because it's just going to ignore the deposition part, but this is gonna help you read whatever is being deposited on the sensor. Okay, so we're gonna leave it like this as of now, because we're gonna go to a previous recipe and then have a look. But remember, source sensor 4 on source 4. Right now we're gonna modify this one here. So edit, and then you have a lot of stuff. Initial rates, basically you wanna know how fast you are going to start to deposit. This basically determines how much power is gonna be input into the system whenever the recipe starts. We're gonna leave it at 0. Final thickness, we're gonna leave it at 0, because remember we are going to be using time. Okay, so we're gonna use the time set point here, edit, and then we're gonna tell it 5 minutes. This is a good start for you to load the sample, run the recipe for 5 minutes, take it downstairs, measure how much you got deposited, and then divide it by the time, the thickness by the time, you know the deposition rate per minute, and then you will know how much time you need to deposit for a specific thickness. Make sense?
Okay. So like you are not quite sure about how the thickness you deposit. So you need to measure first.
Yes.
But you will,
especially with new materials, right?
Yeah. But if you got like oxygen, it will like maybe got some reaction with your material. So
same thing.
How do we deal with that if you got oxygen?
Okay, we'll go for oxygen for the gases after, but yes, you will do the same, right?
Okay.
The material will not change in terms of the recipe will not change in terms of the set points of time or anything like that, right? Okay. But if you have a reaction, maybe you have a less deposition rate, so you have to measure how much of reacted material.
So if you will have the reaction with oxygen, you can have another sample and you have another set deposit.
Yes, of course. Okay. You need to measure.
You will
again.
not like deposit on the original one.
Yeah.
Okay.
So we're gonna leave it for C.
Are you saying atmospheric oxidation?
No. He's telling you if you have reactive sputtering. So if you have oxygen, for example, you need to react with silicon and then deposit silicon dioxide.
Okay.
The amount of silicon to silicon dioxide, so the density of silicon dioxide is lower than silicon, right, when it's sputtered. So you will have a thicker material when you have a reactant. So these kind of things you need to measure all the time whenever you need to know how is it that you're gonna, how much time you need to deposit for a specific thickness. Normally you will say, okay, I need 200 nanometers of aluminum, for example, but how will you calculate the time? All you have to go is measure the deposit 5 minutes, go downstairs to the profilometer, measure the thickness after 5 minutes, the thickness that you get divided by 5 minutes, and then you will know the deposition rate per minute, and then you need 200 nanometers, you just make the calculation, right? Okay. So, time set point, enter, and then we're gonna go here, start mode, we're gonna change it to automatic, okay, auto, enter, and then the sensor 1, because it's source 1, it should be enabled. if you don't enable the sensor, unfortunately, the tool is gonna make it's gonna complain and it's gonna tell you there are no sensors enabled. Please enable one. So just keep it enabled even if you're not gonna be using it.
Okay.
Enter. This is very important. Which source is it deposited? We have it in source 1. If you have it in source 2, change it to source 2. Okay? Max power. There is a rule of thumb for this. Normally, metals, you can go up to 60-65%. Insulators, I wouldn't go above 20%. Even if you have a very low deposition rate.
Okay.
Why? Because we don't have active cooling of the targets. If you keep sputtering at very high powers just to increase the rate, what will happen is that basically you will break the target and they crack. You saw the targets, they break. Once they crack, they are useless. Okay? So, rule of thumb, metals, 80%, 65% insulators, which include semiconductors in this case, 20, 25 at most. Don't go above that, you will break the target. Okay? Minimum power, basically you leave it at 0.
So it just depends on your target, not depends on the substrate.
No, it depends on the target only. Yeah.
Okay, only that part.
Yes. So I'm gonna be on the safe side. I don't want the target because it's new and it doesn't have a cooling plate. So I'm just gonna give it up to 50% in this case for aluminum. But it normally has a cooling plate on the back, and then you can go up to 65. So okay, minimum power 0 is fine. Power alarm delay 99 seconds. Slew rate. The slew rate.
So if you change the power, what could happen? Like you will get a more deposition rate.
Yes,
Okay.
a higher deposition
So
rate.
like you keep the same power, but you change the time, it will also have the effect.
Yes, yes.
Okay, alright.
Then basically that's basically it. This is all disabled. Something that is important is the slew rate, which you are gonna see on a previous. So basically that's it. We're gonna check a different recipe now, so you guys can see. Sorry. Yep. So as you can see, auto, everything. This is different. These two are different because we are using time. Source 1, max power. You see Niobium.
Okay.
He's using 21.4 because he might break the target. The slew rate is important. The slew rate is basically how fast is going to go up from the minimum power to the maximum power, because you cannot just go and inject powers straight away because you will break the target. So you normally need some time and it needs a ramp. Yes. Okay, so we're gonna go and back and do the same thing for ours. So there's training here. We're gonna change the slew rate. You don't want to keep it at 99.9%. So this is aluminum, so we can probably do 10 is fine. Okay. After
How far
that,
can we go with the metals?
sorry.
How far can we go with the metals?
I will never go above 10%, even if it's metal, because all you are doing is risking the target, and the only difference that it makes is that instead of reaching maximum power and start depositing after 1 minute, it will take 2 minutes, which makes no difference whatsoever, right?
Final time is still 5 minutes. The total time will
Yeah,
not change.
total time is
Never change.
in the position time, not this part. So the area of the, if you see the graph, it will be something like this. If you see the graph, it will be something like this. It will ramp up, and then it will just
Okay, yeah.
is
Okay, constant.
constant. Yes. The time that it takes into account is only the constant time. This time is not taking into account on those. So it's fine, right? So you don't need to just risk the target for this. Let's also make sure that we are, this is thermal. We're gonna see this this is fine. Okay. Let me just make sure something. We also have to make sure that something that I forgot is that we have to make sure that maximum power here is also set to the same. We're just gonna set it to 50 as we set the oil. Next, enter previous menu, and that's it. Recipe is created. Okay. Now comes the gases part. We have 3 different gases. Yes, argon, oxygen, and nitrogen. Okay, they are controlled here. It says gas controller. So, hand me that book over there. If you have any questions, this is the SOP as well. So, you can see here, verify gas flow. Argon, nitrogen, oxygen, and 4 is not used. So, argon, number 1, nitrogen, number 2, oxygen, number 3. To verify the set point, all you have to do is press this one up. The set point is set to 19.91. The maximum that we can flow is 20 SCCM for each one of them. 20. So the set point for oxygen, for nitrogen is 0. The set point for oxygen, to check the readings, you also have to turn this knob. The set point for oxygen, nitrogen 0. The set point for oxygen, it's 5. But since we're not gonna use it, it doesn't really matter. So we go back to argon. We're only gonna use argon. If you need to use oxygen, basically you will need to make sure that you have your set point is set. How you set the set point is with this. You need a small screwdriver. No, it needs to be a small flat screwdriver. Let me try to get one very quick. So let me try to get it. So here you press up, and then it's not so easy to see, but basically you can change it up. Down is counterclockwise, up is clockwise. We're gonna keep it on 19, but you just have to turn it. We're gonna keep it at almost the max, so 19.9. Okay, we're gonna keep it there, and we're gonna leave this one here. And you got the, so you press up and then change here in this hole. Remember to change this hole, right? The one that says next to set point, this hole. Yeah. Otherwise, not the Z. The Z, leave it. Don't touch. Okay, so we make sure that the set point is correct. Now, what we can do is switch on the gas. We need argon, right?
Yeah.
So we switch on the gas. And it's not flowing. Why is it not flowing? Okay, maybe it's just... Okay, now the second part. What we are gonna do is use this part, which you have to confirm. Set point 1, 6 milliliter, which is the deposition set point, and set point 4, 20, which is the strike set point. What this will do is that it will first go to 4, strike the plasma, and then go to 1. If it's not there, if it's not set to those values, or you want to change them, you have to press local, enter, then pressure mode, and then change the value. But we're gonna and change the value, and then we're gonna keep pressed and set point save. Okay, that's how it works. After that, you press local again, enter, and now it's remote. Now everything goes back to normal, and you're fine. So now we are ready to start. So you basically click start. You can see that it's flowing the gas. Then it is stopped by itself. Sometimes it happens. You can start. So now you have this one is going to start rising. You can see the power is going slowly, right? This one is also going up. Okay, and if you stand up, you will see. Not yet. It hasn't. We don't have power yet. We don't have plasma yet. Probably needs time. Okay, we don't have plasma yet. Why is there no plasma? There's no plasma. Oh, my gosh. Yeah, now it's plasma. Right? So I'm gonna stop it.
So when it has plasma, it has a light.
Yeah, you can see the plasma either, right? I'm gonna stop it, and then we're gonna go back because maybe something is wrong here in my recipe. Alright, let me just make sure here. One max power system, power 10.
Is it our recipe? Can you recheck this? I think.
Sorry?
Can you recheck? Is it the same recipe?
This one is the one that I'm gonna make sure that it's working fine. Also for max. Training. Where is it? This is so annoying. tell me if there is plasma, right?
No.
No, right? Not yet. Oh. This one is going too slow. Is there plasma? No.
No.
No. I just want to make sure something. It's way too slow. Why is it so slow? There's not enough power to strike the plasma. I don't know why it's so slow.
God.
Oh, it has plasma running.
It has plasma now?
Yes.
Okay. But it's still very slow to go up, which is very annoying. Still plasma there?
Yes, yes, yes.
Okay, there was something missing, and I'll show you right now what was missing. But okay. Okay, so now that we have plasma and everything, you have to wait. So basically you wait here. Right now it's doing the rise 1, then we do rise 2, and then you need to stabilize. also need to have a look at this. Make sure that you don't have reflected power. If you have reflected power, basically what you're doing is not the power that is going from here is not going into the tool, it's just being reflected into the line. So I normally use this to make sure that we have a good tuning. Sometimes it's very annoying. You just have to manually be moving these ones. Make sure that this one is going down, for example, and then you can turn it down to auto, and then just keep it, because this one goes up low all the time, but it needs to tune both of them. So it's a matter of working with both of them, the load and the tune, to make sure that you don't have reflected power. Okay, so we have plasma, we still have plasma, everything is going fine. Now it's a matter of just waiting for it. Now it's soak. This is what's going on.
Okay.
At some point this soak will change to basically deposit. Now it's rise 2, so it's gonna do a second one. We're getting a lot of reflected power, so we need to turn it a bit. So sometimes what it requires is that you keep it in the middle, and then basically pull down both of them to automatic, and then it starts matching everything. So shutter delay. So right now, basically we reached the set point, and you have to do is enable this one. A very little plasma in this one will increase. Oh, this is stopped. Yeah, it stopped by itself. was this one. Yep. I'm gonna start to Can you check it? Power. Now you can open this one. Now I think what the problem is. Okay, so let's have a look at this one.